Hello everyone, how you guys doing? I hope you're doing very well. Welcome back to our class, and the semester is almost done. We're almost finished. So today we want to look at two lessons, 7.5 and 9.1. And so today's lesson, 7.5, is graphing parabolas. That's what it's titled. So we're going to get into it. It's good to see you guys again. Hope you're feeling well. Hope you're being safe. Hope you're very healthy. Continue to social distance. Wash your hands. And just take care of yourself. So, you know the drill. I'm going to get out the way, allow you an opportunity to copy the notes off the board, and we're going to come back and get into it. Sounds good? Okay, I'm back. So let's get started. 7.5, graphing parabolas. Here we go. So we're talking about graphing parabolas. We have a general standard form of a parabola. We have a general standard form of a parabola, and it is y equals ax squared plus bx plus c. That's the general form. And let me add something to this. Let me add where a does not equal 0. A cannot equal 0, because if a is 0, we no longer have a parabola or a quadratic, we just have a linear function. So a cannot be 0. Alright, so that's the standard form. Then we have vertex form, where y equals a times the quantity of x minus h squared plus k, with vertex h comma k. That is the vertex. Now please notice I have some arrows here. This is really important, very important. First arrow I have is right here. This represents the sign. If there's no sign, that means it's positive. The parabola is positive. And if the parabola is positive, that means it opens upward. If there were a negative right here, that would indicate that the parabola is negative and that it opens downward. Okay? This value, this number right here, a, that just lets us know whether the parabola is going to be a wide parabola or a narrow parabola. Okay? If a is between 0 and 1, in other words, if a is like a fraction, okay, 2/3, 1/4, 1/5, 1/6, any fraction that's between 0 and 1, or a decimal, 0.1, 0.2, 0.3, 0, 0.001, that's between 0 and 1, that means the parabola opens up wide, like a wide bowl. If a is greater than 1, then that means that our vertical stretch causes the parabola to be narrower. So if a is bigger than 1, we have a narrower parabola. If a is between 0 and 1, we have a wider parabola. That's really important for a. Okay? And then we get to the minus h. Okay? If we have a minus h, this means h units right. Those that have right capitalized here. Okay? It's the opposite direction. It's opposite. You would think minus h means go left, but no, in actuality, it means go right. Okay? It's going right. H units to the right. Then we have the plus k. Oh, don't forget the square too. Square. Then we have plus k. Plus k means k units up. We have a vertical shift upwards. Okay, we have a vertical shift up k units. If this were minus k, you would go down k units. Okay, this information here is very important. Alright, please, in your notes, make sure it's big, highlighted, color-coded, whatever. Write it, it's critical. We're going to come back and revisit that. Okay? And now we're ready for example number 1. Let's get down to business. Alright, example 1, y equals negative 2 times the quantity x minus 3, quantity squared, plus 4. Question 1, does the parabola open upward or downward? Well, let's see. What is the sign right here? Do not look at the number. That's a. We don't care about a. What is the sign? Is the sign positive or negative? Good. It's negative. Since the sign is negative, it opens down. That's all you write. Alright? So you write opens downward. That's it. It opens downward. All right? Question 2. Is the parabola wider or narrower than y equals 1/4 times quantity x plus 7 squared minus 5? Just look at A. All right? Well, what is the A right here? All right? So in our equation, A equals 2. So A is 2. Well, how about down here? What's A? A is 1/4. Compare those two numbers. Okay? Is this number wider than this one, or is this number narrower? Remember, we said if this number is greater than 1, it is narrower. So that means that this function right here, this parabola, right, is going to be narrower, and this parabola is going to be wider, because that number is between 0 and 1. So the question, is the parabola, this one, wider or narrower than what we have right here? And the correct answer is, it is what? Good, wider. Very good. Wider, right? Wider. No, not wider. Narrower. Look at it. It equals 2. Narrower. Because our A is 2. So it's narrower. All right. Very good. Once you know something, stick with it. All right. What is the vertex? Well, the vertex is HK. Well, our H in this case is right here, H and K. Notice this. We have a minus H here, minus H, but I did not write minus H right here. I wrote the positive H. I didn't write the minus, I wrote positive H. Even though here I have minus H, but in according to point, it's positive H. And the reason for that is because this positive H right here is what causes our argument right here to be 0. The positive H causes our argument to be 0. So our vertex in this case is going to be positive 3, positive 4. So the vertex is 3, 4. That's the vertex. Negative H, but in the vertex, positive H. All right. Negative 3 in the vertex, positive 3. Okay, very good. When x is 2, what's the value of y? Plug in 2 for x, see what you get. All right, so here we go. We have y equal negative 2 times x minus 3 quantity squared plus 4. So now plug in 2 for x. Let's see what happens. Alright, so we're going to have y equals negative 2 times 2 minus 3 squared plus 4. And now what's the matter with just doing arithmetic? Just simplify it down. That was another black. Let's see, so we're going to have y equal negative 2 times negative 1 squared plus 4. So y equals, see, negative 1 squared is 1, and 1 times negative 2 is negative 2. Plus 4, and so y equals 2. And there you go. So when x equals 2, y equals 2 also. So I got the coordinate point 2, 2. That's the coordinate point. So when x is 2, y is 2. Just plug it in. All right? How many zeros? How many zeros does the parabola have? Well, here's how you determine the zeros. Look at this. All right? The number of zeros is determined by the power. If the power is squared, that's how many zeros. So how many zeros does the parabola have? 2. 2 zeros. That takes care of that. According to the power. That's it. All right. Find the zeros. There should be an S. Find the zeros. Well, find the zeros. Well, you find the zeros by letting y equal 0. All right. So here's what we have. We have y equal -2 times x minus 3 squared plus 4. Wherever there's a y, take out the y, put in a 0. Let y equal 0. So I'm going to have 0 equals -2 times x minus 3 squared plus 4. And then rearrange it. I'm going to write this part. I'm going to write that part first, like this. Let me change the color and write that first. -2 times x minus 3 squared plus 4. So I wrote this part first. Now write equals 0. Yeah, put it in some kind of like some standard form with 0 on the right side. Now let's do let's find out what the zeros are. Okay? So basically, when you find the zeros, all that means is solve for x. That's all we're doing. We have to solve for x. In other words, x equals what? What does x equal? Let's solve this for x. X equals what? Okay? So, in solving this for x, first, let's go ahead and subtract 4 from both sides. -4 minus 4, that's going to give me -2 times x minus 3 squared equals -4. Because my 4's here cancel out. Okay? Now divide both sides by 2. -2. Divide both sides by -2. -2, -2. Notice right here the -2's cancel out. So I'm going to have x minus 3 quantity squared equals -4 divided by -2 is positive. -4 divided by -2 is positive 2. Equals positive 2. Okay. Now we're back at lesson 7.2, I believe. The square root method. Square root method now. You have to square root both sides. So we're going to have x minus 3 quantity squared equals 2, right? And we have to square root the left side plus or minus square root the right side. Remember that? Recall that? Square root method? That's what we're doing now, right? And if we do this, then the square root symbol and the square cancels out. So we're going to have x minus 3 equals plus or minus the square root of 2. Now what must we do? You have to add 3 to both sides. So we have to go plus 3 and plus 3. And remember, at this step, we told you, do not write the plus or minus root 2 first. Don't do that. The 3's cancel out. So I'm going to be left with, the 3's cancel out, so I have x equal. And you write the plus 3 first. So it's going to be a positive 3 plus or minus the square root of 2. And that's pretty much going to do it. Now go ahead and split them out. Split it up. So let's write our 2 answers. Let's separate them out. So x does equal 3 plus the square root of 2. That's one solution. That's one answer. Or or x equals 3 minus the square root of 2. And those are your two answers. Because you told me there you had 2 zeros, right? Look, 2 zeros. And we found them. There they are. Those are your two answers. Here's 1 0. That's one solution. And here's the other one. We have both of them. There we go. X is either one or the other. Okay? Now it says find an additional point. Find an additional point, you let x be whatever you want x to equal. It's up to you. What do you want x to equal? Alright? Let me see. Let x equal 1. Let x equal 1. Well, when x is 1, find y. No problem. So, here I go. Y equals negative 2 times x minus 3, quantity squared, plus 4. You said x is 1, right? Let's do it. So when x is 1, I'm going to have y equals negative 2 times 1 minus 3 squared plus 4. See that? I'll put in 1 for x. And so y is going to equal negative 2 times, what are we going to get there? Negative 2 times negative 2 squared plus 4. So y is going to equal negative 2 times 4. Because negative 2 squared is 4. Plus 4. And so y is going to equal negative 2 times 4 is negative 8. Plus 4. And so y equals negative 4. There you go. So when x is 1, y is negative 4, and that's the coordinate point. Coordinate point is 1, comma, negative 4. You might be asked to find 2 points instead of 1. You just choose your x. I chose x equal 1. Alright, you choose another x. Let x equals 5, 7, 8, whatever. It's up to you. You choose. And that's what you'll get. Okay? And so there you go. And so this is how you find all the characteristics of a parabola that's given to you in vertex form. See this? This was vertex form. We have the A, we have the H, we have the K. So this form was already in vertex form. It looked like this right here. It looked like y equals A times H, x minus H quantity squared plus K. So that was given to you in vertex form. And so if you're given a parabola that's already in vertex form, here are the characteristics. Here are the characteristics of A, H, and K. It's right here for you. And this is how you proceed. This is how you proceed to determine whether it opens upward or downward. This one opens downward because it's negative. If this were positive, you would say opens upward if it were positive. But it's not positive, it's negative, so it opens downward. Alright? We know that this parabola that we were given, it is narrower than this one because 1/4 is wide and 2 is narrow. So this one right here is narrower. You know that? The vertex, well, the vertex is HK. Alright? Our sign here is negative. Negative H. We have a positive H right here. So since we have a negative 3, we want to go 3. And the K is 4. 4. And this whole vertex form, we're going to talk about it somewhat in a few minutes. We're going to talk about it a little bit more, give you a little bit more clarity on this HK. We're coming to it in a second. Alright. When x is 2, find y. So go back to the original equation, put in 2 for x, solve it out, you get y equals 2. Alright, so once you evaluate it, well, not solve it, you're doing more evaluating. This is evaluation. When x is 2, evaluate the parabola at x equals 2, and you get y equals 2 also. So we have 2, 2. How many zeros does the parabola have? Look at the power. The power is 2. It's a quadratic. Power 2, it has 2 zeros. Well, Find the zeros. What are the zeros? In order to find zeros, you let y equal 0. In order to find zeros, that means solve for x. So we let y equal 0. So we have -2 times the quantity of x minus 3 squared plus 4 equals 0. So now take this expression, this equation, and solve this equation for x. And we did that. And we got x equaling 3 plus root 2, or, not and, or, because you can't be both at the same time. That's like saying, that's like saying you are 16 and 25. You can't be both. If your name is Michael, Michael can't be 16 and 25. You one or the other. So x equals 3 plus root 2, or x equals 3 minus root 2. So we found the two possible zeros. And then we found an additional point. And that's it. Given a parabola in vertex form. Now we're going to look at a parabola that's in what? Standard form. And we have to take the standard form and transform it to vertex form. That's what we're about to do right now. All right? You ready? All right. Stay tuned. Here we go. Okay. So now, as we transform from the general equation of a parabola to the vertex form of a parabola, I've written some more notes up here on the board. Take a minute, pause the video, copy them down, and we're coming right back at you. Cool? Thumbs up? All right, I'm out. And I'm back. All right, here we go. So, if you want to go from the general form of a vertex, of a parabola, to the vertex form of a parabola, there are 3 ways that you can do that. Maybe more than 3, but I'm going to give you 3. So you can choose the one that's most beneficial or the one you're most comfortable with. So I'm giving you options. That's the universal design for teaching and learning, giving students what? Options. So I'm going to give you 3 options. All right? Let's get down to business. All right, so what we're going to do now, we're going to go from the standard form, which is also the general form. Standard and general are synonymous in this case. Standard form to vertex form. In other words, we're going to go from the blue form, and we're going to transform the equation and make it look purple. From blue to purple. All right? And here are our 2 equations. They're both given to us in standard form. But we're going to convert them and transform them into what? Vertex form. All right? And I'm going to show you 3 ways to do it. By completing the square, without completing the square, using the vertex, and have an algorithm here, or formula. We're going to use all 3 of them, okay? All right, let's go. Here we go. Way 1, by completing the square. This one is a process. Watch this. So we have y equals x squared minus 6x plus 8. That's example 1. All right, here we go. The first thing you want to do is you want to write y equals x squared minus 6x and give yourself some space. Write plus 8 out the way somewhere. Write it out the way. This term right here, move it on over. Give yourself a little space. And so now what you want to do, at this stage you want to complete the square. Okay? And remember, go back to lesson 7.2, I believe. When you complete the square, you take this term right here, you take half of it, and you square it. Alright? So if I take this term right here, and I add, so it's going to be a plus -6, take half of it, and square it. Okay? Now notice this. If I add it, I must also subtract it. -6, take half of it, and square it. So I took that middle term, -6, half of it, squared it, -6, half of it, and squared it. So what I did was, I added it and I subtracted it. It's like I gave it and I took it away. So in essence, The black up here is still the same because I added it and I took it away. So it's like I really did nothing, but I did a whole lot. All right, watch. Here we go. So we're going to have y equal x squared minus 6x, all right, plus, here we go, negative 6 divided by 2 is negative 3. Negative 3 squared minus negative 3 squared plus 8. So I'm going to have y equals x minus 6x plus negative 3 squared is 9 minus negative 3 squared is 9. Now here's where I want to associate our group. Oh, I left off the square. Don't forget the square. So now I'm going to group this together. Okay? And the reason I do that is because now I have a trinomial square. The first term is the perfect square, the last term is the perfect square. A trinomial square here. So I can factor that as y equal x minus 3 quantity squared. So I write the trinomial square now as a binomial square. And if you're saying, Mr. Wright, I don't understand, what did you just do? If you want to understand it, you might want to go back to lesson 7.2. It was lesson 7.2 when we talked about completing the square. Yeah. See, these lessons build upon each other, you know. If you understood 7.2, this is a breeze. If you didn't understand 7.2, you do not understand what I'm doing right now. So you might want to stop and say, let me go back and get a refresher on lesson 7.2 and you'll be fine. Okay? But for those who say, Mr. Wright, I got it. Y'all come on. Let's go. All right? So we have x minus 3 quantity squared. We have a negative 9 plus 8. That's negative 1. And we're done. That's it. That's a wrap. And we know that the a, in this case, is a 1. Because the a right here is a 1. So we don't have to write the 1. That's not necessary. And that's in vertex form. With the vertex actually being 3, negative 1. Okay? But Mr. Wright, how do I do it without completing the square? Because this right here, I don't like doing all that. Okay, no problem. Well, you try this one. You try this. Let's write it out. Y equals x squared minus 6x plus 8. All right, if we're going to use our formula, we have to recognize that it asks for a and b. What's the value of a in this case? A is 1 and b is negative 6. A is 1, b is negative 6. B is negative 6. So the vertex is negative b over 2a, comma, f of negative b over 2a. All right, so here we go. So our vertex is negative, see, negative, negative. Well, what is b? B is negative 6. It's the negative of negative 6 divided by 2 times a. 2 times, what is a? A is 1, comma, well, let's see here. Before we fill this in, let's go figure this out right here. Let's do it again. So v is the negative of negative 6 is positive because a negative times a negative is a positive. So it's going to be 6 divided by 2, comma. Keep going. So v, 6 divided by 2 is 3. All right, now we're ready. So Mr. Wright, what is all of this stuff right here? What's all of this? I don't get all this. That looks confusing. What does all that mean? Some of y'all looking like, I don't know what all that f of b, f of negative b divided by 2a, what's all that? What's all that? All right, here we go. I'm about to show you what it all is, right? So we have our h. See, it's positive 3. See that? Minus 3. Remember that? Minus 3. That should be a 3. We got it. Now we're going after this 1. So what you do now is you take this 3 and you put it in the function. Put 3 inside of the function. So I want f of 3. That's all you do. Take the x value and plug it in for x. Let me write it out. Plug in 3 for x. That's all you have to do. Plug in the 3 for x and find out what y is. Let's do that. So y is going to equal 3 squared minus 6 times 3 plus 8. Tell me what y is. Let's go. Y equals 9 minus 18 plus 8. Y equals negative 9 plus 8. Y equals negative 1. There you go. That's what's missing. There's your other part of the vertex. So the vertex is 3, negative 1. So you got it now. Watch this. So we know that h is 3. You know k is negative 1. You know a is 1. So now take all of these values, 3, 1, and 1, and plug it back into this form right here. So if y equals a times x minus h squared plus k, take those numbers and plug it in. If I take those numbers and plug it in, I'm going to get, let me write it up top a little bit. Let me erase this. And let me write it right here in the middle. H is 3, K is 1, and A is 1. And the form is y equals a times x minus h squared plus k. Take those numbers and plug it in. So y equals 1 times x minus 3 squared plus, and k is, oh, I'm sorry, it's negative 1. Plus negative 1. Now we write it. We don't have to write the 1. So we got y equals x minus 3 squared plus a negative is just negative. And there you go. That gets it too. So this is the same as that. So you can complete the square. You can do it using this method right here with just giving the vertex and putting the vertex back into the form. Or you can use the algorithm. It's the last method. Algorithm, well, what do we have? Y equals x squared minus 6x plus 8, I think, yes. In this case, you identify A, B, and C. A is 1, B is negative 6, and C is positive 8. Take those numbers and literally plug them in, and that's it. That'll put it in vertex form. Let's plug it in. So we're going to have y equal x plus negative 6 over 2 times 1 squared plus 4 times 1 times 8 minus negative 6 squared over 4 times 1. Once everything is plugged in, do the arithmetic. That means multiply, subtract, add, divide, do the arithmetic. Okay. Y is going to equal x plus, what do we get there? Negative 6 divided by 2 is negative 3 squared. So y is going to equal, plus a negative 3 is just a minus, x minus 3 squared. Well, look at that. We halfway done already. X minus 3 squared, look. X minus 3 squared, look. X minus 3 squared. There you go. Like I always say, if you can add, subtract, multiply, and divide well, you can do anything in mathematics. You really can. But you have to do those things very well. And so what we did was, we multiplied, divided very well, and we got our x minus 3 quantity squared. Alright, let's do the same right here. Alright, plus 4 times 1 times 8 is 32, minus negative 6 squared is 36, divided by 4 times 1 is 4. So we're going to get y equals quantity x minus 3 squared plus 32 minus 36 is negative 4 divided by 4. So y is going to equal x minus 3 quantity squared. A positive times a negative. A positive times a negative is a negative. 4 divided by 4 is 1. There you go. There you go. Now, that's it. So choose the one you like. Whichever one. Whichever one was pretty simple, was, you know, the most convenient for you, use it. Okay? A good student learns all of them. It's up to you. There you go. One more example. Let's do another one. Erase this. Erase this. In fact, if you want to, you can pause the video and try the example by yourself. I recommend that. And you choose the method you like. Now we're going to do this one right here. We're looking at y equals negative 3x squared plus 24 x minus 42. And we're going to do it with completing the square. Alright? So here we go. We start off again. Same way we did example 1. Alright? So we have y equal negative 3x squared plus 24x. Move the minus 42 way over. Minus 42. Leave some space. Now in this case, watch this, ladies and gentlemen, because you have to factor. The greatest common factor here between, you got to factor the GCF between these two terms. Factor out a negative 3. So we're going to have y equal negative 3. See that? Negative 3 times x squared minus 8x. Leave a space, minus 42. So we factored out the greatest common factor, which is negative 3. Why? Because negative 3 times x squared is negative 3x squared, and negative 3 times negative 8x, a negative times a negative is a positive 24x. Okay? Alright, now we have to complete the square. Here we go. So now, we're going to have y equals negative 3, here we go, times x squared minus 8x. Alright, now, take half of 8. Half of 8 is what? 4. 4 squared is what? 16. So I'm going to go a plus 16 right here. Now I know what you're thinking. If we go plus 16 right here, then we have to go a minus 16 outside, right? Wrong. No. The minus 42 goes here, yes. But what goes right here? What goes there? We know this is 16 because this negative 8, we took half of this negative 8, took half of it. And then we had to square it. So negative 8, half of that is negative 4. And negative 4 squared is 16. That's how we got this 16 right here. So you say, okay, plus 16 here, minus 16 right there. No. Because you don't have 16 right here. It's negative 3 times 16. That's really what you have right here. Negative 3 times 16. What is negative 3 times 16? Because that's what you have. What is that? Negative 3 times 16 is a negative 48. So you're really looking at negative 48. That's what we have right here. Negative 48. Because negative 3 times 16 is negative 48. So since I have negative 48 right here, I have to go the opposite and put a positive 48 right there. That's what goes right here, plus 48. Yeah, you gotta watch that one. Gotta watch it. Alright, let's go. So if that's the case, and it is the case, we're going to have y equals negative 3 times, okay, factor this. Take the trinomial square and write it as a binomial square, which is x minus 4, quantity squared. And then I have 48 minus 42 is plus 6, and there you go. That is in vertex form. Okay? Some of you guys saying, Mr. Wright, I was with you till you got to that 16 and that 48 stuff. I didn't like that. Well, I tell you what, stop the video, watch it again. Okay? Let's go on to our second example. Let's try it right here. Here we go. So we have y is negative 3x squared plus 24x minus 42. Identify A and identify B. What is A? What is B? A happens to be negative 3. B happens to be 24. All right, let's find the vertex. So V equals negative B, negative 24 over 2 times A, 2 times negative 3. Let's do the work on that first part. Let's do our arithmetic very well. Come on, let's do it. Let's go. That's going to be negative 24 over 2 times negative 3 is negative 6. And what is negative 24 divided by negative 6? A negative divided by negative is a positive. That's going to be positive 4. All right, we got it. Good. It's positive 4. Okay, so I'm going to take this away. Well, no, I'm going to leave it. I'm going to write under it, V is positive 4, comma. Now, plug in 4 for x. Plug in 4 for x. Let's do that. So y equals negative 3 times 4 squared plus 24 times 4 minus 42. Y equals, at this stage, be very careful with your arithmetic, order of operations. We're going to get negative 3 times 16 plus 24 times 4 is 96 minus 42. So y equals negative 48 plus 96 minus 42. Negative 48 plus 46. Y equals 48 minus 42. And so y has to equal 6. We got it. There you go. So when x is 4, y is 6. That's our vertex. That's our HK. So H is 4. K is 6. And whatever you do, do not forget A. A equals what? You can pick up the A from right here. That's what A is. This is your A. See that? That's A. See that? Here's A. A is negative 3. Take those numbers and put them back into y equals A times x minus h squared plus k. Plug them in. If I plug them in, I'm going to get y equals negative 3 times x minus 4 squared minus, what's my k? Plus 6. Same thing I got right here. The exact same thing. I get it there as well. All right. There it is. I get it right here. Got it. The exact same thing. Got it. All right, so this is that. Last way, that way. Here we go. What do we have? Y is negative 3x squared plus 24x minus 42. So A is negative 3, B is 24, and C is negative 42. That's our ABC. See that? A, B, C. Plug it in. Y is going to equal x plus 24 over 2 times negative 3, quantity squared, plus 4 times negative 3 times negative 42 minus 24 squared, all divided by 4 times negative 3. Careful with your arithmetic. Use a calculator. In fact, I think I'm going to pick mine up. I think. Let me see. Some of this I can do without a calculator though. Let me see. Y equals x plus 24 over negative 6 squared. Y equals x. Well, 24 divided by negative 6 is going to be plus negative 4 squared. So y equals x. A positive times a negative is minus. Minus 4 quantity squared. I'm almost there. There's my x minus 4 quantity squared, which is right here, which is also right there. Okay. Now, be careful on all of this stuff. All right, plus. Here we go. Where's my calculator? Let's see here. We have, let me see, I have 4 times negative 3 times negative 42. That's going to give me a positive 504. 504 minus 24 squared. 24 squared is 576. All divided by 4 times negative 3 is negative 12. So y equals x minus 4 quantity squared plus, here we go, 504 minus 576 is negative 72 over negative 12 So y equals x minus 4 quantity squared plus, does anyone know what a negative divided by negative is? You do? Oh, that's wonderful. A negative divided by negative is a positive. So here we go. Negative 72 divided by negative 12 is positive 6 plus 6. Will you look at that? Oh my goodness. Oh my goodness. This is beautiful. 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 There you go. There are all three methods. It works, folks. You choose. Okay? You have three methods. You can get with this, or you can get with that, you can get with that, and you can get with... Okay, you know where I'm going with it. You know where I'm going. You choose. Thanks for listening. Thanks for coming by. I hope you were able to follow along. If not, watch the video again. If you have any questions, text me, email me, reach out to me, and I'll be more than delighted to help you and to go over this again. All right? And whatever you do, continue to social distance, continue to wash your hands, continue to stay home, and by all means, stay absolutely positive. Okay? Will you do that? All right. Take care. See you next time. Hello guys. Okay. Welcome back. Now we're going to look at lesson 9.1, which is graph translations. Hope you're doing well. Hope you're feeling fine. Hope you're ready to get started. Let's go. So, take a moment, write down the notes, and I shall return. I'm back. Okay, let's get started. 9.1, graph translations. So here's the most important thing. Translations. H. H represents opposite, opposite. Say opposite with me. Come on, say opposite. Opposite. You're going to mess it up, aren't you? I hope not, but we'll see. H represents opposite, horizontal movement. Here's what we mean when we say opposite. It's just like our last lesson, 7.5. Minus H, that means go to the right. That's right movement. Minus H is right movement. Plus H is left movement. It's not what you would normally think. Okay? Minus H, minus, you move to the right, not left. Plus H, move to the left, not the right. Okay? For the same reason I gave you in the last lesson, lesson 7.5. Okay? K. K represents vertical movement. Minus K, well, that's exactly what it means, downward movement. Plus K means upward movement. Minus K, it translates vertically downward. Plus K translates vertically upward. Okay? This is important. This explains everything we're about to do. Everything, literally. Right here, point 1, point 2. You understand point 1, point 2, you're going to be okay. Alright, so what we're going to translate, parent functions. The general form of the function is the parent function, right? We're going to take the parent functions and translate them. So we have a linear equation here, a linear line, a linear function, linear equation. We have an absolute value equation. We have a square root equation, quadratic equation, and we have a hyperbola here, a rational equation. This is a hyperbola 1 over x, which is a rational equation. And here we have their translations. Okay? So that simply means that we're going to add a plus or minus h and a plus or minus k to the parent function. Here are the parents, and notice I just added either a plus or minus h and a plus or minus k to each of them. That's all we did. Okay? And what this does, this informs us of what? Horizontal or vertical movement. If it's h, it's in parentheses or in the absolute value or under the radical. So anything that is confined, right? H is always opposite. So it doesn't matter. Let me see. For example, if it's the if it's parentheses, absolute value, if it's a radical, it does not matter what the confinement is. Whatever the h is in here, if it's a minus h, if it's a plus h, if it's a minus h, it's always opposite the sign. That's the movement. So this minus h here, it's in parentheses, that means I'm going to the right. This plus h in absolute value bars, that means I'm going to the left, opposite. Minus h under the radical, that means I have horizontal movement to the right. So whatever that h value is, if it's inside of the containment, you go opposite direction if it's inside the containment. Whereas k, outside. See, k is outside of the containment. And if k is outside the containment, you just go in that direction. Plus k means up k units. Minus k means down k units. Plus k means up k units. So the h on the inside go opposite. K on the outside, well, you go in that direction. You got it? That's important. That's key. Let's look at a few examples. And that's it. Here we go. All right, so what you have to do, ladies and gentlemen, is translate these parent graphs into the blue translated functions. So all of my parent graphs are in black. Parent, parent, parent. Here's the graph, here's the graph, here's the graph. Parent function, the graph. Parent function, the graph. Parent function, the graph. Oh wait, how do I want you to translate this one? Let me see. Let's go, I didn't write this one out. Let's go y equals x plus 2 minus 4. And don't forget the square right here. There we go. Let's translate that one. Y equals quantity x plus 2 squared minus 4. All right? So the parent function is black. In black, the graph's in black. Parent function in black, the graph's in black. Parent function in black, graph is black. Parent function in black, the graph is black. So I'm giving you all the parent functions, and they're in black. I need you to take every parent function and translate it to the blue function. That's what the blue function is, what we're about to sketch. We're going to sketch every blue function on here. This blue here, this one there, this one there, this one here, that one here, this one there. So I'm giving you the parent function, I'm giving you the graph of the parent function, and now we're about to translate them. Okay? Alright, let's go. Let's start translating. Please notice this. Notice, here's the key. For every parent function, right, please notice I have a green dot. See that? Green. 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 Have a green dot at 0, 0. Except for the hyperbola, I have a -1, -1, and 1, 1. To translate these, it's just a matter of taking the green dot and moving it according to the horizontal and then vertical movement. That's all we're going to do. All right? Here we go. So for the first one, let's look at the horizontal movement first, and then the vertical movement. Let's do it. This says horizontal. This says 2 left and 1 down. So take that green dot and move it 2 to the left, 1, 2, and then 1 down, right there. And then draw the parent function. I took the green dot, I went 2 left, 1, 2, and 1 down, 1, and that's it. And here's the graph. It looks like this. That's the translated graph. And we're done. That's a wrap. See that? This says 2 left, 1 down. 2 left, 1 down. Green dot. 2 left, 1, 2, 1 down. 1. That's it. We translated it. We moved it. We shifted it. Okay? How about here? What are we doing here? What is our horizontal? What is our vertical? What's the horizontal? What's the vertical? Horizontal is to the right one. So I'm going one right. This one is 3 up. So go one right, 3 up. We can do that. Take the green dot, go 1 to the right, and up 3. 1, 2, 3, 1 right, up 3, boom. There we go. And sketch it. And that's it. That's going to do it. That's going to do it. How about right here? What's the horizontal? What's the vertical? That says 2 to the left. 2 left. And then 1 up. Let's do that. 2 to the left. 1, 2. And then 1 up. Puts me right there. Sketch the graph. In other words, sketch the parent all over again. And that's it. That's all we're doing. What about here? Horizontal, vertical. This one says go 3 to the right and 2 down. Let's do it. 3 to the right. 1, 2, 3, and 2 down. 1, 2. Right there. 3 to the right, 2 down. And sketch. Okay. That's done. All right. What does this one say? What's the horizontal? What's the vertical? Horizontal. 1 to the right. No, I'm sorry. That's 1 left. That's plus 1. So that's 1 left. This one is down 1. That's the vertical. So we're going 1 left and down 1. So it doesn't matter which green dot you use. In other words, if I move this green dot, the other one by default on your computer is going to move. If I move this one, the other one by default is going to move. So if you're given a question like this, you don't have to move both of the greens. Choose one and move that one, and the other one will move by default. So from here, if I go 1 left, go 1 to the left, and then down 1, that's going to put me right here. Here, if I go 1 left and down 1, it's going to put me right there. All right, so sketch the graphs. It's going to look like this. And there you go. That's it. And what do? We want 1 left. It's 1 left because of this one. That plus 1, that means 1 left. And then this right here means down 1. Down 1. And this right here is left 1. So I went left 1, down 1. Left 1, down 1. And there you go. All right, how about right here? What does this tell us to do? What's the horizontal? The horizontal is 2 left. And the vertical is 4 down. Let's do that. Let's go 2 left, 1, 2, and let's go down 4. 1, 2, 3, 4. 2 left, down 4, right there. All right, sketch. Boop, boop. These are the sketches, by the way. That's over. What about here? What's the horizontal? Horizontal is 1 right. How about the vertical? Vertical is up 1, or 1 up. Let's do that. Let's take it right 1, and let's take it up 1. And there we go. Right one, up one, and there it is. All right. What about this one? What's our horizontal? Let me write it over here. What's the horizontal? The horizontal is 4 left. What's the vertical? Vertical is 3 up. Let's go 4 left. 1, 2, 3, 4. Let's go up 3. 1, 2, 3. 4 left, up 3, puts it right there. Now sketch it. Okay, that's done. Last one. What's the horizontal? Horizontal is 1 right. And what's the vertical? It's 3 down. All right, let's move the green dot. 1 to the right, 3 down, 1, 2, 3, boom. And sketch. I think lesson 9.1 is probably the shortest lesson I'm going to teach this semester. Because basically that's it. That's all you have to know about graph translations. If you have any questions, comments, issues, scares, concerns, worries, woes, didn't get it, couldn't get it, redos, do-overs, retries, do it again, you know, anything like that, just hit me up. Text, email, reach out to me, and I will help you out. All right, continue to social distance yourselves. Stay home. Wash your hands. Keep your hands clean. Stay out of your face as much as possible, especially your eyes, your nose, your mouth. Stay away from those areas. And we'll get over COVID-19. It'll be all right. It'll pass over soon. So take care. Thanks for listening. Thanks for watching. And whatever you do, continue to stay positive. All right? Will you do that? All right. You can do it. Take care.